Okay, hi everybody, and welcome to today's MAPP webinar. This webinar today is going to be jointly hosted by Modeling, Analysis, Predictions, and Projections MAPP program, and also by the Climate and Societal Interactions, or CSI program. The speakers we'll hear from today represent the diverse communities supported by these programs. They work on projects that run the gamut from developing foundational understanding and improved prediction and monitoring techniques to identifying and supporting best practices that ensure that climate-related needs of decision-makers are met with reliable and accurate information and services. Martin Hoerling from NOAA Israel and Eric Wood from Princeton University are members of MAPP's Drought Task Force. Mark Schaefer is the Director of Climate Services for the Southern RISA, which is supported by CSI's RISA program. And Mark Svoboda straddles both communities with projects funded by both the MAPP and CSI SARP programs. Along with Marty and Eric, Mark is a member of the MAPP Drought Task Force. So a little bit on the Drought Task Force. It's composed of 30 investigators who are funded by the MAPP program. They're engaged in a number of activities which build off the individual projects funded by MAPP. One activity is to create drought narratives which explore the predictability and prediction of major past droughts over North America. This activity is led by Marty Hoerling, and the activity produced a report on the 2012 Central Great Plains drought, which is available on the MAPP website. Another task force activity is to examine how research improves capabilities such as monitoring and prediction of drought. The group involved with this activity developed protocols to enable quantification of the impacts of research on existing capabilities. And in his talk, Eric Wood is going to touch on the issue of research to capabilities. So I'm joined here by Claudia Nierenberg, and I wanted to give her the opportunity as the deputy of the CSI program to say a few introductory words.
I just want to thank you for participating. I think that we're getting far closer to integration over time between connecting practical needs and planning and preparedness to the research capabilities and monitoring prediction. I know that all of the speakers are, participants also in the NIDIS program, and both CSI and MAPP support NIDIS's end-to-end efforts in linking the monitoring, prediction, and impacts, capacity, and outreach. So thank you very much, and I look forward to today's webinar.
Great, thanks, Claudia. So Marty is our first speaker. Marty, are you on the line?
I'm on, Dan.
Okay, great. I'm going to transfer control over to your desktop.
All righty. Okay, very good. So thanks, Dan, for organizing this, and Claudia, hello, and everyone, good morning. Why drought regimes is the question I just want to have us think about in the few minutes that we have. In many ways, we live in the shadow of the Dust Bowl. Individual droughts, Dan mentioned, we recently studied in some detail the 2012 event, which came on the heels of the Texas drought of 2011. These individual events still create the fear that a new Dust Bowl might be creeping back into our current culture and lives. In fact, I think it was in the summer of 2012, near the height of the most recent severe drought in the Great Plains, that John Nielsen Gammon, who's a state climatologist in Texas, wrote an op-ed piece for the New York Times. And he was sort of trying to calm some of the fears that we were entering another Dust Bowl. He had this interesting statement. He said, calling the 2012 drought a Dust Bowl is like talking about a no-hitter in the second inning. I like this baseball analogy. But we have quite a few no-hitters of 9-inning duration in our climate record. And that's what I'd like to share with you a little bit. Here's an example of a long time series of America West drought regimes based on a reconstruction from paleo data of the Palmer Drought Severity Index. It's sort of an iconic figure. For those of us that really look at problems of drought and water in the West, this is a figure that we often have to begin with to at least address the question of, boy, things had been bad in antiquity, if you will. If you look at the time series in the years 800 to 1300, the lines being elevated indicate that a significant fraction of the West was covered by drought of a modest to moderate severity, at least. And the recent period in this time series, by comparison, is not nearly as persistently dry. It's generally been wetter until perhaps the last decade or so. So one of the questions that has certainly come up in dealing with drought and in the West in particular, is whether the conditions that happened at that time were unique to something occurring in climate then. And we no longer need to worry about that because climate has changed, we know that. And the factors that are now operating that drive climate variability are not the ones that led to the prolonged multi-decadal droughts in about 1,000 years ago. Here's just a snapshot. This data set that's produced by Lamont scientists and Ed Cook in particular is a very powerful data set. You can go in and you can make your own composites and create images such as this from a paper that was published recently by Ed Cook and colleagues at Lamont. And it just shows two snapshots. On the left is a period 1276 to 1297, a 22-year period in which drought was severe in this region called the Puebloan region, if you will, of southwest America, and then another period of severe drought only lasted maybe about 6 years in that data set. But the point is that these types of events harken back to concerns about the Anasazi and the stresses that the society went under in those times, of which climate was a factor. Exactly how much of a factor is unknown, but multi-decades in which water resources were scarce is certainly something that has happened before. The question is, can it happen again? And now, in this age of more knowledge about drought, can we anticipate such happenings? Give you an example of a part of the U.S. where drought regimes in the instrumental record have been very prominent. And the Missouri River Basin is an integrator of water that falls over a large catchment. The river itself is I believe it's the longest river in North America. It's about 2,340 miles long. By volume, it's not very voluminous. It ranks only 9th in North America in terms of flow by volume. It's because it drains a semi-arid region. But because of the semi-aridity of the region, the variability is quite high. In about 1940s or so, the Pig-Sloan Missouri Basin Project came into force based on the notion of controlling floods in the Missouri Basin, especially down at the junction at St. Louis with the Mississippi. And reservoirs were built. Nowadays, about 3 years of water storage exists on the Missouri Basin. So to some extent, short-term droughts have sort of been mitigated by having massive storage, but long-term droughts continue to be of great concern. So this next slide is an illustration of the record of the annual flow above Sioux City, Iowa, illustrating from 1898 to 2011 that there are periods of 10 or so years in duration in which the annual flow in the river is well below the 50 percentile, which is 24 million acre-feet. You can see the 1930s to early 40s and the late 50s, early 60s. And then most recently, 2000 to 2008 was a prolonged drought. And then suddenly it was punctured by this tremendous flood year in 2011, in which the annual flow exceeded anything that's been observed in the instrumental record. Extreme variability, but this regime-like behavior is the thing I want to just bring to your attention in the Missouri Basin. Now you can do this analysis of a Palmer drought index in the instrumental record as inferred from temperature and precipitation measurements that covers the whole U.S. from 1895. Here's a time series updated through July of 2013, where you see high spikes. That's where more of the U.S. was covered by moderate to severe drought. This is using a threshold of 3 units on the PDSI. And you can see there's regimes in which drought was more prevalent. We now seem to be in such a regime, and the question is whether this regime is going to be long-lived or whether we're going to quickly move out of it. So how do we address these kinds of questions? I just want to give you a quick flavor for some of this. And, you know, one study that comes to mind really that is a bit of a watershed study in our science was published in 2004 in the magazine Science by NASA scientist Zig Schubert was the lead author, that gave some indications that we had a handle on what may have caused the drought during the Dust Bowl period, related to ocean conditions in the tropical Pacific in large part, and also involving complexities of how the land interacted with that. And so that was a bit of a breakthrough in our field. Only 10 years ago, we began to get some understanding of what may have caused this decade-long occurrence of the Dust Bowl period. Here's an analysis of a climate model somewhat more advanced than what was available to the NASA group back 10 years ago. Using the NCAR CCSM4, this model has been run over a 500-year period in which there is no change in greenhouse gases. It's just a run of the model coupled to the ocean and the atmosphere to see what is the characteristics of drought in this long integration of the model. Does it look like the Cook time series, for instance? So the leading pattern of soil moisture, we're using this as a proxy, is shown in the upper left, shows a nationwide pattern as the leading domain of variability. And to the upper right is the relationship of that pattern with ocean temperatures. It very much confirms the results that Siegfried and other studies, Lamont scientists, Richard Seeger have led these types of studies recently also, showing that there is a tropical Pacific Ocean relationship with drought over North America, giving us some hope that there could be predictability, good news for predictability, if we can anticipate those ocean temperature variations. That time series of the pattern is very striking because you can see long runs in which one phase of that North American regime of either wet or dry seem to be in place for decades at a time. So in many ways, the model recreates the type of characteristics we saw in the paleo data. Now here's another rendition of doing these types of modeling experiments to get at the causes and predictability. Here we repeat the same type of experiment, but we don't have any ocean variability in this case. We just allow the atmosphere to go about its chaotic behavior. We let it relate to the land, so it's coupled to land variability. What comes out of this analysis is a little bit more dark, because what it tells us is that without any involvement of the ocean, you can have a North American-wide pattern that dominates drought, and that's again shown in the upper left. It looks just like the result from the coupled ocean-atmosphere model. But the time series, as you see in the lower right, the lower left side, also has these regimes. In fact, some very long regimes that remind us of the time series in the paleo record. But in this case, these regimes have nothing to do with the ocean. So this is sort of a potentially challenging, significantly challenging result for us to sort out as to why these regimes happen without any involvement in the ocean, and what might be the predictability is an open question for these types of behaviors. The other point I just want to raise is these experiments that we've done are using climate conditions of the current early 21st century. So the factors that may have produced the severe dust bowl or the factors that may have produced paleo drought seem to still be operative even today. Here's just an example of another pattern from this atmospheric model for the southwest, the Puebloan region, and you can see its center of action is centered over Arizona. It's mainly a warm season phenomena in the model to some degree. But look at that time series. 20, 30, even in the last 100 years, one phase of that pattern was dominant. So this is one of the research challenges. So just to wrap it up, last slide here. Why drought regimes? What is it that we need to do? What do we do within CPO under MAPP to make progress? Well, we have to ask the questions, how are North American drought regimes conditioned by forcing? Ocean temperatures, can we foresee those ocean conditions? So what is the predictability of the indicators that may be early warning indicators for long drought regimes? And then I didn't get into this, but what does global warming have to do with this? Recent occurrences of drought have been blamed on this is emergent global warming. We need to sort out what global warming is contributing to the duration and the frequency of drought over North America. With that, we'll close.
Thanks very much, Marty. I'm going to see if there are any questions on the phone line or here in the room for Marty. Okay, any questions? Okay, Marty, thanks a lot. Appreciate the talk, very interesting talk. The next speaker is Mark Schaefer. Mark, are you on the line?
Yes, I'm here.
Okay, I'm going to switch control over to your desktop.
Okay. Does that show up?
Yeah, it looks good.
Okay. Thank you, Dan. This is kind of some growth that came out of experience, I guess, with the 2011 and really ongoing drought. And I'd like to acknowledge a few people that were involved in this process, especially Dave Brown with NOAA Regional Climate Services Director for the Southern U.S. that has really led this, Chad McNutt at NIDIS, and many folks at National Drought Mitigation Center, Mark Svoboda, Brian Fuchs have been involved with this. This is, it was a RISA response, really, some of the programs from the recent perspective here that we were able to engage with stakeholders in this region, and kind of some directions for future research questions that came up from those interactions. So what I'm going to highlight, first of all, a little bit of the background in this part of the world. Marty laid an excellent example there of these kind of drought regimes, and many of the ones with 1930s, 1950s that we've had in Oklahoma's history. You can see the 1930s Dust Bowl, that extended period, the 1950s, which was, until recently, at least statistically, the most severe drought in Oklahoma's history. An extended period of wet, and then kind of returning to some of those drought regimes. So that's kind of what we're dealing with. People got used to it being wetter around here, and we've gone back into this dry. The reason that the drought is such a problem in this area is we're right on that borderline where we have evapotranspiration exceeding annual precipitation in the western part of the region, shifting to more wetter areas in the east. So if we get a dry year, it can quickly tip that balance and become major impacts very quickly across western Oklahoma, central Texas. Of course, western Texas has always has a lot of challenges. This is the evolution of the drought. It started in October of 2010, as far as when we can kind of first find its roots in showing up in Texas. And then it evolved into a large area of exceptional in drought, D3, D4 levels of drought by summer and fall of 2011. It abated a little bit, and then reestablished itself really more in the northern plains, or central northern plains, during 2012. In both cases, Oklahoma was in it both years, and Texas had a little relief in 2012, but they really went back into it in 2013. So this has been around. It's been shifting around and affecting a lot of people. Fortunately, we've seen some improvement recently. So here's some of the impacts of when it came on in 2011 that we saw, especially the livestock industry was really hit. This was a time we learned that the industry was trying to build up the number of cattle nationally, and it really knocked them for backwards on that effort, leading to some of the lowest cattle inventory in decades. We've had record low water supplies that still persist in central Texas. The lower Colorado River through Austin has some major challenges still remaining with it, as well as some irrigation lakes in southwest Oklahoma and Wichita Falls area, Texas. Very severe wildfires in Texas and New Mexico. Seen a lot of water main breaks as the soil contracted. The water main breaks 700 a day in Houston at the peak of it, and up to 500 million trees killed, and impacts extending down into Mexico. So we have we tried to engage people to find out two things. One is we wanted to get the information, what we knew about the drought's evolution and forecast or outlooks, to get that information out there. So a lot of work with CPC in getting those outlooks. But we also wanted to learn how people were managing it and what kinds of questions, what kinds of challenges they were having. So there are several strategies. NOAA, RCSD, and NIDIS led these drought outlook and assessment forums was one aspect. Marty participated in one of these. I think Mark has participated in at least a couple of them, and they were 5 that we've had in person where we could bring stakeholders, and these stakeholders are practitioners, people who are involved in land management, especially water management, were in attendance and had really good discussions. So the first part of it in the morning was really on the evolution, the current conditions and outlooks, and then the afternoon we focused more on whatever was relevant to that region and the management strategies. A few things we learned: we've improved the communication. We were able to explain to people in participation there how the longer term Pacific Ocean conditions were affecting these drought regimes. We tried to communicate that. Apparently they received very well. We got some feedback that we need better guidance on product interpretation, so some education aspects of how to understand and apply some of the products that we produce. And people were really interested in the explanation of causes. They really wanted to know what was behind, how El Nino and La Nina affected the patterns, much more than sharing management strategies. They really wanted to hear more of the science. We then broke off of this and developed a webinar series. Started out bi-weekly, going to monthly. They're a little less frequent now that the drought has eased in this region. But pattern after those Outlook and assessment forums, we tried to engage people. The advantage of doing the webinar series is we could reach a much wider audience at once without having the logistics of travel. So we had the overview part of it, and then we had the discussion topics. So we talk about water resources, or we'd explain how seasonal forecasts are made, or a variety of topics on that. And then had comments and updates from our state climatologists. So that gave them another area that they could reach out to all these people and tell them more at a local level what's going on in their states. And these were all posted on YouTube. Then this evolved in 2012 into a weekly drought briefing series. We realized that these webinars are about an hour long, and a lot of people don't really have the patience to sit there and watch or participate in a whole hour-long webinar. So, but we wanted to keep that information, especially the Outlook information, as current as possible. So we developed these 5-minute briefings that we post directly to YouTube. And this helps us manage the workload so we can keep people engaged with this. We found that people are still viewing these briefings, even though drought conditions have lessened. And it gets around some of the problems of arranging presenters and having to do an hour-long thing. So this was patterned after that status and Outlook part that really originated from those assessment forums. So, so with that, here's some of the things that we've learned that maybe opportunities for further research in the region. One of the first was kind of a development of a tool. We had we recognized when we did some of these water resources webinars that the information was held by different agencies and presented in different formats, very hard to compare across regions. So the Army Corps of Engineers may have something different than the USGS or some local water districts or Texas Water Development Board. Different ways of displaying information. So we worked with our partners, the Southern Regional Climate Center, to develop a common database and developing some common visualization tools so that we don't have those boundary issues. We even found actually that there were variations in the way information was presented from one Corps of Engineers office to another. So the way the Tulsa office did it was different than the way the Fort Worth office would display it. So so what we're trying to do here is build a regional system where you can see the entire water resources at a glance. This actually came out of a suggestion by some of the participants, some of the stakeholders that we engaged with who are in the water management business, especially Texas. So NCDC and the RESA provided some funding to develop this, and it's about coming out right now. It's in the final development stages, and trying to make it easier to compare. It also will give us a capability, because we're trying to populate this backwards, that we can look at how these reservoirs responded, especially how they recovered from previous droughts, and as well as floods and other factors can be applied. So, so with this, we can trace over time. We can trace the reservoir levels and see kind of the drought and then kind of recovery. There's elevation capacity curves, so you know where you are on that. We can also put some metadata information. This is Canton Lake in northwestern Oklahoma. You can see the water level, and then as it drops off, the boat ramps start becoming inaccessible, and you can see the levels where those are inaccessible. And there was a huge drawdown here for the Oklahoma City metropolitan area early in 2013, to the point where none of the boat ramps were accessible. If this information had been more known, maybe they could have drawn just a little bit less to keep one of those boat ramps accessible, because it really has hurt the tourism aspect in that Canton Lake area. Another project that emerged from this was we started calling it initially Pictures of Drought. We wanted to take a look at the impacts of drought and how it looked on the landscape, because you see a lot of kind of chatter on the drought monitor discussion, and people post pictures and say this is such and such drought, and pictures are often, they don't really align always very well with some of the other indicators. So this is an effort we're just starting out to try to look at a more systematic way of trying to match those visual indicators with some of the other indicators that we do use in the drought monitor a little bit more systematically. So we partnered with CocoRa's to ask their observers to take pictures of landscapes all at the same time across the entire country. So this was done initially in September of 2012. We did a field photos weekend. We called it field photos so that people even in the wet areas would participate. We didn't want them thinking, oh, I'm not in drought, so I don't have to worry, I don't have to participate. We want to see what it looks like now, because a year later it could change. So we've done this now 4 times. We have a comparison from Labor Day 2012 and Labor Day 2013. Those are all online through another partner here at OU. And what we're wanting to do is harvest this now to look at landscape changes with in relation to some of those drought indicators in the drought monitor itself. Another issue that came up was measuring the impacts of drought, and this has been discussed a long time. Some of the early NIDIS meetings that's been going on is how do we quantify the impacts, especially the secondary and tertiary impacts that are associated with it. So when we have, we often can do the kind of estimated crop losses be the major impacts, but what are the impacts on businesses, closing, on restaurants, and on tourism, and then also psychological, ecological impacts. So we've been trying with NDMC for several years to try to get a large assessment project going. We are doing NDMC is leading 2 drought assessments right now, one for the 2011 Southern Plains and one in the Central Plains 2012 Midwest. But still trying to dig down to those really detailed levels. So we're now, the research is working to try to take a single county and try to get every single little bit of connection that's been in drought on and off for the last few years, looking at household finances, decisions, delayed purchases, things like that, non-economic losses. Another thing is parts of the Panhandle regions and up into southeast Colorado. These pictures on the screen were from Lamar, Colorado in May 2013, and it really does look like the Dust Bowl pictures, just colored versions of some of those pictures we saw in the 1930s, and that is a wheat field, or normally wheat field. So this has been going on for several years in some of these places, and we've started to see people move away, starting to abandon the land, much as they did in the Dust Bowl. So what's driving these changes? So the social changes that are behind that, and how, if people really learn, have they forgotten the lessons from the Dust Bowl, or is there something different going on? How are people coping? So that's another area that we can see some future research in those kind of those semi-arid areas as you get some desertification going on. And lastly, we just wanted to highlight a lot of work we're doing with our partners CLEMAS and NOAA and NIDIS with the Rio Grande, Rio Bravo basin. So across New Mexico, Texas, and Mexico, developing a quarterly climate outlook that will be available both English and Spanish. So we have some challenges there, putting together the way the information is presented. For example, seasonal forecasts from Mexico are done differently from seasonal forecasts from the U.S. So how do we combine those in a way? The reservoir information, things like that. Trying to put together a quarterly climate outlook, but then see how people use it and look at their scenario. We're going to do a workshop next spring led by CLEMAS, Greg Garfin, who's going to do a workshop to look at short-term and long-term adaptation strategies in the water issues that are really extensive along the Rio Grande. So those are just some things that have emerged, and all of these are really driven by people asking for this kind of information. And I think there's opportunities really to collect with a lot more of the physical research that goes on programs like MAPP and others to really try to close that gap. So that's a little taste. I'll turn it back to you, Dan.
Thanks a lot, Mark. Thanks for providing that bridging perspective, too. And some of those impacts were surprising, very interesting talk. So we have time for a question for Mark. Anybody on the phone line or here in the room have a question?
I have a question. I have 2 questions, actually. Mark, that was a really tough. Yep. I had a question when you were talking about the webinars, and you were talking about how they reached out to more audiences and more participation. Did you get into questions of evaluation of whether early warning information made it into early action? Was valued in certain settings, and how?
Yeah, we did a survey of our webinar participants fairly early on, about 6 months after we've been doing these webinars, and we had some questions on there that asked how they use the information, and it was there's some research on utilization that kind of goes into, you know, not just receiving the information or using it as background, but did they make effort? Did it change your perspective? Did they use it to try to change somebody else's perspective? In other words, how much did they take this and push it to others? So we had some question on that, and actually found that I can't remember the numbers offhand, but probably about a quarter of them had actually reached that level where they said they took some of this information and they went and told other people. And we had some opportunity for them to tell us specific changes that they may have made in their decision making, and we had some qualitative information on that. We are planning to repeat that survey. I'd like to get that out there here probably just right after the start of the year, because it's hard to get survey responses. So so we're planning to go back and see, now that it's been a couple of years, how much has changed.
Did you see, like in the case, you mentioned the case specifically where there was variation even across some of the Corps of Engineers offices and how they would present the data? Do you get any response, you know, in the cases like that where the Corps of Engineers might respond to your translation and transformation efforts and work line there?
This survey was just a very we tried to keep it very brief, so we didn't have the kinds of questions we needed to break down. As far as say this Corps of Engineers kind of responding. I believe we did have some level. Are you kind of in agriculture? Are you in water resources? We did have some of that. I don't recall that. I don't think we did that kind of a breakdown yet, but
yeah,
that's something we definitely want to look at with you know, more now that we've had a couple of years to go back and do that.
Thank you.
Thanks for the question.
I think we actually have to move on,
okay,
but maybe at the end if we have a few minutes left.
Okay.
Yeah. Sorry, Caitlin. Okay, so thanks a lot, Mark, for the talk. Our next speaker is Eric Wood. Eric, are you on the line?
I am.
Okay, great. I'm transferring over your desktop. And there's a lot of noise in the background here, so make sure that you actually mute your phone and not your WebEx connection. So actually push the mute button on your phone instead of pushing the mute logo on the WebEx.
Okay, I'm going to talk a little bit. It fits in very well with Mark's because this is a sort of thinking of a risk-based capability to estimate the probability of drought recovery. The sort of current procedures that are out there tend to look at total precipitation, and that doesn't really give a good sense of what the risk of recovery is. Sort of the challenge is, you know, why we started to think about this and build this off of our hydrological seasonal forecasting work is it's really critical that we get a useful procedures. You know, seasonal forecast models have poor skill in predicting drought duration and recovery, and yet we need these improved skills for improved drought management. And so this sort of led us to think about how we could do a risk-based drought recovery procedure, allow users to assess the potential decisions in a stronger decision-making economic framework. And build upon the research that we were doing for MAPP. Here's some stuff from that I drew. This is the top part is our drought monitoring and forecasting system that we host. The top three panels show some forecasts for the drought in 2012. It was initialized in the beginning of July with CFSV2. And you can see as it goes from July, August, September, you show a weakening of the drought. That's the forecast in CFSV2. And the bottom part, the verification, shows that, in fact, there really wasn't much weakening. You know, you see that it's still strong. You see some wettening down in the southeast with the North American monsoon system. And so this is very typical. I mean, almost all the, if you look at all the forecasts for different droughts, I mean, if you did this for 2011, it would be much the same. So it's a chronic problem that frustrates users in trying to make decisions. So we did some stuff. Here's a paper that came out in GRL, which you can get details of what we've done. This came out this year, earlier this year, and you can go look at it. Ming Pan, who is one of my research staff, led this work. So the approach presented here builds on our seasonal forecasting. It uses ESP, which is a procedure that resamples from the historical meteorological data, precipitation, temperature, and current hydrologic initial conditions. And so this will then produce an ensemble of future hydrologic states, and in our case, our drought index, but you could use it also for stream flow, and you know, there's all sorts of things that would build off of this one. So just to show how it fits into what we're doing, and we've transitioned, we haven't transitioned this part, but we've transitioned this hydrologic modeling prediction system over to EMC over in NCEP, and they're running it as part of the climate test bed. And so generally what we do is that we have multiple ensemble forecasts, and we're doing with the NMME work now some historical observations, and we merge all this together. We produce from this merged, downscaled, bias-corrected data set. We generate 1/8 degree daily forecasts that go into land surface models. The monitoring part of this in NLDAS uses 4 land surface models. The forecast part that we've transitioned over only uses 1, and that's an upgrade that needs to be done. But you take the initial conditions from the monitoring part over on the lower left, and these forecasts, and then you get ensembles of river discharges, drought indices, and you think of drought management. And so that's one thing. In the ESP part that we now have built to do this drought recovery, we use these historical observations. This is the SP. So we have these historical weather ensembles. We have the initial conditions into the land surface model that produces ensembles of the drought index and the discharges. Now, the challenge that happens is that here's a little, shows what happens in on the forecasting. So we have a limited number, and we use about 50 years of historical data over the forecast period. So you get these forecasts, and what we decided to do is to fit a distribution to the ensemble members to be able to get a much better, more robust risk assessment of what would happen in the forecast period. And so that is an important component of this, and you'll see why when we show some results here. here are some results for 2012, 2013 in the upper Midwest drought. This happens to be a grid scale analysis. It's one of the figures in the paper. So what you see here, this are different leads starting. I can start my computer. We can go home. We start later. So what we see here is different leads and the cumulative precipitation percentiles for the half month 1.5 all the way out to basically the 6-month forecast, all initialized beginning of February. And then every dot there is one historical precipitation temperature evolution. And so the scatter that you see, so if we go out to the one in the upper right, the scatter that you see, even though the cumulative precipitation, and so the light green is at the 50th percentile, the scatter there has to do with how the rainfall and the temperature variability comes. You may get the precipitation early in that forecast period. You may get it later, and so that gives you different risks at the end of the forecast period of whether you'll be in drought or not in drought. And you can see that for the first month for this particular grid, there was 0 probability of recovery above the 30th percentile. Those are the red line. And then at the 2.5-month lead, if you have sort of the median rainfall, there was like an 18%, and if you get the 70th percentile of rainfall, there's something like a 63rd. And so we fit these distributions using some Copula procedures so that we have some bivariate information in there. And so this basically helps us compute the probability that soil moisture will exceed some threshold. And you can see that in this case, as you go further out, there is a high probability that, in fact, you'll get a recovery given the historical observations fit to these distributions. The background gray is sort of the density functions from these distributions. The red X is the median of the precipitation that would cross that threshold. Here's some maps for the recovery above a threshold, the 30th percentile, given the median probability of the required accumulative precipitation, which is the red axis. And so every place that's dark red, like in the upper right hand at the half-month lead, will never recover. And then as you move through these, you can see it moves more to the green and the blue. These are all initialized on the 1st of February, I believe, in 2012. And so you can get a spatial percentage. And what happens is that the median probability of the required accumulative precipitation tends to fall as you go further out using this historical historical ensembles. This is similar, looking at a different way, the recovery probability at the median precipitation. So if you get the median precipitation over there, how does it look like? And so this is just a different way of looking at the same problem. And this is a drought recovery analysis for some half-degree boxes. So you can do this over any particular. You can do it at a point. You can do it at a box. This happens to be an area in Georgia that was initialized in May 2007, and the bottom is a Texas box initialized in May of the Georgia is 2007. The Texas one is in May 2011, and you can see then see that evolution. What is interesting down in the Georgia, the southeast one, is that in the long leads that you just get results which are all over the place because of the variability on how the precipitation gets delivered in that 6 month, whereas in Texas it's much tighter distributions, especially when you go out 3 month leads. And so this, so if you had some fairly good cumulative forecasts, and I think that some of the seasonal forecast models might be able to give cumulative precipitation over a 3 month period, as opposed to how that precipitation gets delivered in time. You could combine that with this sort of analysis to get a sense of what the probability of recovery above a threshold might look like. And I think there's some potential to do some additional research. In fact, we're doing that, looking at what we call these canonical events of how skillful is sort of a cumulative 1 month or 2 month periods for precipitation or temperature values. And that could be combined with this sort of ESP approach to give you more insights from the risks and would help management. So in summary, you know, our NLDAS research we've been looking at seasonal drought monitoring forecasting products that have been transitioned over to NCEP, and but we've done more research that hasn't been on looking at probabilistic drought forecasting with this ESP methodology, and we can increase. I think this can be used to increase operational capabilities at CPC for providing drought guidance, and can be used in conjunction, as I mentioned, with the CFS forecast, and do a combined merge. So that's my summary of what we do. Any questions?
All right, thanks a lot, Eric. So there was a lot of noise on the line last time, so what I did instead is polled the attendees to see if they have a question. You send me a chat message and let me know if you have a question. I can unmute you so we can do it in a more targeted way. And I haven't gotten anything back yet, so I'll give it another moment and just see if anybody sends me a message to unmute them. Any questions in the room for Eric? Okay, well, I'm not seeing anything through chat, so thanks a lot, Eric. I appreciate the presentation. Okay, Mark, are you on the line?
Yes, I'm here, Dan.
Okay, great. I'm transferring control over to your desktop.
Okay, thanks again for the invitation to present. Can you see the talk yet?
I can't see the talk. I see the beautiful iceberg.
Yeah, it must have switched monitors. How about that?
That looks good. Thank you.
All right, is it full screen? It looks like it's not full screen, but...
Not yet, no. Just, yeah, if you can go to presentation mode. Yeah. Oh, there's a dialog. Yeah, there you go. maybe you can just roll through them in this view.
Yeah, I guess it's messing up something between my two monitors.
Why don't you just go down to the bottom and hit the, yeah, try that one.
I tried that too. For whatever reason, it doesn't seem to be liking it.
Yeah, I think this would be all right. If you let's see, down on the bottom right, there's that little magnifier thing. You can just pump it up to fit all the way. Yeah, that to the right of that. If you click, yeah. If you click that button to the right of the plus sign, it'll just maximize it. There you go. Yeah.
Okay, we'll try that. Sorry about that.
No, no problem.
Okay, so I'll be pitch hitting for Mike Hayes today. He had to be called out of the office. So put together some slides to give folks a little bit of an idea of the activities we're doing here at the Drought Center and how research is driving how we interact with our stakeholders. So we're all about trying to help people plan and reduce their risk to drought. Most of you on the phone are probably aware, or on the webinar, aware of this. So I won't dwell a lot on this with the boring flow chart of who we are, but the reason I showed this slide of our staff is to give folks an idea, the diversity of our staff, geographers, rural sociologists, geographers, climatologists, GIS and geospatial analyst types, outreach and facilitating types. That's really what's allowed us, I think, to tap into a lot of different programs and work with a variety of partners and audiences and end users along the way. As a boundary organization, you know, our main goal is to hopefully bridge and translate science to the public, to policymakers, to decision makers, and the media. So the media is a big part of the mouthpiece of us getting our message out, both in an operational sense and also with regards to a lot of our extension and outreach. And, you know, there's a big project underway right now through USDA, U2U, useful to usable. That's been our mantra for a long time, is really making information that's usable, not just delivering something on the loading dock and saying, here you go. And I think the way you do that, obviously, at least our MO has been to involve our users right up front in that process, and then incorporating their feedback to help guide and drive our research and development. So when we do finally get ready to hand off and make something operational or take it out to the masses, that at least there's a greater sense of ownership that they've had in that process, and it allows us, I think, to be responsive to more of the current needs of that user base in developing our tools. So when they hit the road, we feel like we're still pretty caught up to date with what they want and what questions they want answered. So let me skip over this. So our research and activities, outreach and education are split amongst these three program areas. The one that I oversee, the monitoring, in essence, is a lot of our operational capacity. I'll touch on a few of those tools for decision support here in a minute. Also, our planning and social science that many of you know Cody Knudsen. I've worked with him over the years. Cody's heading up that group. And then we do have a GI science group that works on visualization, large database integration into these decision support tools. And that's a lot of work. So there's a lot more to it than just looking at a nice pretty map at the end of the day. We focus on that end-to-end continuum there at the bottom, the research to applications, operations, and education. So obviously we're not just a research shop, but a little unique in the university environment is we also maintain quite a few operational tools with our partners. So over the past few years, we've been able to hit quite a few areas across the United States, typically where drought has had an impact, is usually where we're called in to come in and put on workshops or forums or listening sessions or work with focus groups. And even globally, there's a map there, the inset in the bottom right, that gives you a feel for some of the workshops we've at least organized or helped conduct. Not the ones we've just attended, but rather had a role in organizing with partners at various entities, which I'll show on a global map here on the next slide. So you can see we typically focus on a lot of the rural areas. A lot of our workshops are out there with producers, typically as the main audience, but also with state officials and even federal folks as well. And a lot of times those folks are working with us to conduct these workshops and getting the word and message out, trying to get feedback on which way do we need to go with developing these decision support tools in our research program. And so we really take heed of that when we're going through that process. This map just shows more of the international flavor, because this plays an important part of gathering lessons learned from around the world. We've worked with a variety of these countries in the orangish color there on your map, with the UN and some of the aid agencies, and then also a lot of universities and national ministries and governments around the world in all theaters, and continue to do that, bringing scientists in here, going there and visiting. It works both ways, and that's really exposed us to state-of-the-art, not just here in the United States, but also it's important to understand the needs and what's going on around the world, and so I think this allows us to keep in tune with that as well. So if you look at the cycle of disaster management, a lot of emphasis obviously paid to the red on the bottom half of this graphic, looking at crisis management. Once the disaster comes and causes damage or loss of life, you've got the response, recovery, and reconstruction. We tend to focus up here on the proactive risk management part of the equation, particularly with regards to mitigation. And for us, mitigation is any action you take in advance of or at the beginning of a drought to reduce your risk. And through two main thrusts: one, the planning, and also through monitoring and early warning, as well as prediction. We don't do any prediction per se here. We rely on partners for that, and working with others that are producing those sorts of products. We're more focused on monitoring, early warning, and planning, which I'll touch on here. So first on monitoring and prediction, obviously sort of the bell cow of that has been the partnership with USDA and NOAA over the years, since the late 90s, in developing this weekly U.S. Drought Monitor map. This combines several indicators that run the whole gamut, from remotely sensed to LDAS-type products to observed in situ type of products. But it also involves some 350 on the ground, what we call local experts. And many of you on the phone might actually be some of those experts. I know there's a few on. And we lean heavily on those folks to provide us the guidance. I think, the stuff that Mark Schaefer showed illustrates nicely, seeing those photos, getting those reports from those state agencies that aren't typically broadcast out nationally all the time, is a really great feedback mechanism to let us know if our indicators are reflecting reality on the ground. Kelly Redmond and others have always said, if you're not being impacted, are you in a drought? And quite frankly, we haven't done a great job traditionally of collecting impacts as sort of a baseline activity in our country, and really globally for that matter. So as any part of a real drought early warning system, that we're working with other entities now, taking advantage of the technology in these developing countries. It's amazing going out and doing workshops in developing countries, and they have a tremendous amount of access to cell phone technology, where they can take a snapshot of an impact or record a precipitation amount, any other observations they're seeing, and then push it right up into a database or a server, or to an entity like a ministry. We've seen that in countries even as dilapidated as say Mali. And that's something we're not taking great advantage of quite yet. I think the apps are going to be coming, but this is an area that I think we need to focus on, sort of this crowd imaging, if you will, or sourcing of data and information. Another tool that we worked on in partnership with the U.S. Geological Survey and USDA Risk Management Agency is the Vegetation Drought Response Index, which combines remote sensing information with climate information and biophysical parameters. But the point I want to emphasize on this particular tool or process is that we had user groups or evaluators, if you will, that were set up throughout the states as well that would do, generally a rough windshield survey, but they are able to sort of validate surrogate-wise sort of what they were seeing on the ground and if it matched these maps that we were producing every 2 weeks. With the MODIS system now, that's done weekly with this product, and many other countries now are interested in modeling off of this. Maybe not the exact same inputs, but they are interested in the process and the method. So that's one thing we're doing with our partners as well. I spoke about drought impacts earlier and the need for that. We did develop through funding through SARP at the time a drought impact reporter and database that's been online since 2005 and is growing, especially with the droughts. We've been in a pretty active drought pattern really ever since this database came online. And this continues to evolve. We just pushed up a new version of this a little over a year ago, and obviously allows for anybody to come in and enter in impacts, which then goes to a moderator here at our center that scans through those and enters them into the database. So we do feel the biggest connection we've seen to that user base outside of the media, which a lot of these are electronically culled from through a clipping service, but we went into a partnership with CocoRoz a couple years ago, and that is really beefed up. They have a network of around 15,000 people out there. We build in a drought impact interface in their interface that then brings it as a conduit into our database pretty seamlessly. We have to moderate those too, but it's a separate layer that comes in that's nice and is right on the ground. A lot of photos come along with those as well. So that's been a really great partnership with CocoRoz. And getting citizen science sort of off the ground, people take a great interest in contributing to these sorts of products. Planning, just a couple tools here to emphasize. Since I'm not in my view, I can't show you everything in the order I'd like to, but the basic thing is here from the bottom left to the top right, we're moving from planning at all scales. From the at one time, state planning was the big thing, but now we're seeing a move towards individual and community planning, and even basin level planning, that activities like we're doing with NIDIS. So managing risk on the ranch was aimed at producers, involves a lot of producers. Drought Ready Communities was another program funded by SARP that worked with partners at University of Oklahoma and Illinois. And at the state level, that's been what Don Wilhite had worked on for decades, and we continue to work with several states in their drought planning, and then up to the national and international level. The two most recent ones that came online were this drought management database on the right there in the middle, and our work with American Planning Association through NIDIS to develop a planning advisory service guide that's aimed at their thousands of constituents and practitioners. That's ready to hit the shelves here in December. I already mentioned managing risk on the drought, so skipping forward, another tool here that was also funded by SARP that we're still working on, have about a year to go on that funding, but we'll be launching the tool for the first phase of it here, hopefully in the next 2 weeks, now that we have all the data in place. So this will help give people a little bit different perspective on planning at the local level. We hope to pursue future funding in the future to sort of seamlessly put in this database of 3,000 stations, nice rigorous database put together, and maybe couple that with something like some of the paleo data. So my final slide here, I've already really touched on the first two bullets, so I'll just skip to the last two and just note that, through our development of decision support tools, that's been our way of sort of bridging that gap between our three focus areas, monitoring, early warning, and preparedness. And obviously our goal with all of these has been to link our scientific knowledge and those of our partners with the actions needed by those folks on the ground that they can put into place, ideally through a drought plan or some other vehicle or mechanism to reduce their risk to drought in the future. And with that, I'll turn it back over to you, Dan. Thanks.
Great. Thanks a lot, Mark. So we do have a question on the phone line from Stephanie Ogburn. Stephanie, are you on the line?
Can you hear me?
Yes, I can hear you. Okay,
great. Hi, Mark. Thanks for doing the presentation. I was interested in the drought risk atlas that you mentioned in your second to last or almost last slide.
Yeah.
I was curious to learn a little bit more about it. So who is the target audience for that, and how is it put together?
Yeah, you know, we've had a lot of interaction over the last couple years, specifically with the state climatologists, but also with state government officials that are interested in three main questions if you're in a drought, you know, so sort of how bad is it now, where am I now, but then they always ask, okay, how does this compare to the 50s, how does this compare to the 30s, and you know that graphic Mark Schaefer showed earlier, and some of the spatial maps that even Marty showed as well. That's the other question, is sort of that analog approach, and then, you know, ideally what you'd like to do is integrate them all and say, well, what does the future kind of look like, and then that touches on some of the tools that we heard from Eric as well. So, you know, that's been our target, has been those sort of decision makers. We've had a lot of interest from some of the river basin planning commissions, and sort of the, you know, we worked with APA too to sort of get this in front of communities and say, when we developed the interface, which you'll see launched in a couple of weeks, the idea was to keep that simple so that it would be usable. So we hope that's what we've done.
Great, thanks a lot. I also was curious about international drought indices. A lot of times I'm curious about whether or not there's drought in other parts of the world outside of the U.S., and it seems a little bit difficult to find out. Is that something that you guys are working on at all?
It is, and several of the people on this webinar today are as well. The place, you know, that we envision seeing sort of a global portal into this view is through NIDIS, through drought.gov. There's a map viewer there. There is a global portal in place now that sort of points to what activities are occurring from a monitoring, early warning, and prediction standpoint in all the other continents, in fact. I mean, there's stuff in there for China, Africa, South America, Europe, through the Joint Research Center and other activities that are, and the UK as well, that are spinning up and doing some of this sort of work using drought indices and other tools. So I'd encourage you to track that down if you want to. Follow up with me if you can't find it, and we'll get you pointed in the right direction.
Thanks a lot.
Great, thanks a lot for the question, Stephanie. Caitlin Simpson, who's here in the room with me, I think had a question for Mark Schaefer. So, Mark, if you're still on the line, Caitlin's going to ask you something.
Are you still there, Mark?
Yes, I'm here.
Okay. So I guess it's a bit of a question for you and maybe for Dan. You had mentioned that there were research questions from the stakeholders that you thought would be relevant to MAPP. So I'm curious, you know, what those questions were in particular, and then maybe from Dan whether you would see MAPP taking them on if you see them as relevant.
Okay, well, I think the number one thing we heard, of course, thing everyone wants to know is how long is this drought going to last? You know, how severe is it going to be? How they want the prediction scale. So it really takes into account advances in seasonal forecasting. Now with the limited skill on seasonal forecasting, what we were able to bring into play was things like La Nina and the PDO through like Marty's work and John Nielsen Gammon's work, and at least say, well, we may not be able to say the next, you know, however many months, but these are some like, you know, bigger seasonal to interannual concerns. And then I'm really interested in the work that Eric showed here, that I think there's great potential there, is getting into kind of probability of recovering, or what if you have normal rainfall, what if you have a bit above normal rainfall, how does that change the odds? And they're really just looking mostly to hedge, because they need, we can do a lot in talking about the status, and they are interested in it, but it's really that you know, when are we looking at recovery, and that's going to affect their decisions. Also, decision timescales. I think there are some key things when they're making their decisions, you know, as far as acquiring resources for what they're going to plant next spring. They're already doing that now, and it, you know, so there's a little longer lead issues there. So I think there's a lot of opportunity there. It's not something we've really tackled so much directly. I think we focus perhaps a little bit more on the social stuff, which is more aligned perhaps with SARP. But you know, physical changes, changes in the landscape, I think changes in wildfire risk, you know, the long-term recovery, I think the lower Colorado River and the Rio Grande River, what we're seeing there is that they're so depleted, what's it going to take to bring them back? So getting into a lot of the hydrology, you know, aspects. So I think there's a lot of potential, and we'd be happy to try to, you know, connect some of the things, you know, look at individual groups that we've worked with and try to make some of those connections with people doing research in that area, and maybe we can help make sure that there's kind of a focused user in there, or a kind of something that'd be good to pilot some tools, people would have some patience to work through some things.
Yeah, so I really appreciate the question. I think it's a good way of wrapping up this webinar, because this is kind of the idea that the things that Mark mentioned are certainly high priority for the MAPP program in terms of drought research, and even the call that we have open, or that recently closed, the proposals were due on November 14th on drought, was, you know, very much in line with what Mark was saying. So it's focused on improving prediction efforts. One part of the call has an element of looking at past droughts and predictability of past droughts, and so in terms of recovery, you know, that area of the call kind of captures that topic. How have past droughts recovered? Were they predictable in terms of the onset and the recovery? And you know, some of the proposals that we're seeing deal with that type of issue. The second part of the call is more targeted at making improvements to the existing prediction systems, and it has a focus on seasonal, but also sub-seasonal to longer time scales. So in terms of needing longer lead time information and better information at those lead times, you know, this call, the hope is that the type of work that investigators funded under the call would perform would end up resulting in improved products and services that, you know, would ultimately be beneficial for the type of work that Mark does. So yeah, it's a great question. And then, you know, the other outlet might be to connect with the Drought Task Force on some of these questions. So, you know, maybe bringing in Mark's perspective, and we have a lot of Drought Task Force members on the line I can see in attendance, but, you know, perhaps having a briefing to the Drought Task Force could be useful, thinking about the research to capabilities question all the way to the user end of things. So yeah, it's a great question. I really appreciate that. Okay, so we're quite a bit beyond the prescribed end time for this, so I apologize. I very much appreciate all of the speakers for taking the time to present today. 4 very interesting talks, and I thought that they arrayed very nicely and spoke to each other. So it was a very interesting webinar, and I appreciate everyone taking the time to prepare slides and speak. Thank you to everyone who attended, and you know, thanks to members of the CSI program for helping to plan this and bring some speakers to it. I think this is a useful discussion, and we'll look for, you know, forward steps from here, like things that I just mentioned, for instance. So this was part of the larger MAPP webinar series, and we're working on pinning down the rest of the series. We do anticipate having a webinar in December, but we haven't pinned down the exact details and speakers for that yet. So you'll see on the screen now some information about the webinar series, and it'll flip in a few seconds and show you the website. Please check out the website. Once we announce the rest of the series, it'll be up there. We also post all the recordings and slides to this site, so you can go back and listen to the talks again, or download copies of the presentations if you'd like. So thanks again, everyone, for speaking and for attending, and we'll talk to you in December, hopefully.